Okay students, let's continue in the second video now. The following table shows the number of rows and the number of students in each row when they are made to stand for a drill. Number of students in a row: 40, 10, 24, 12, 8. Number of rows respectively: 6, 24, 10, 20, 30. Now, from the table, we observe that the product of the number of students in each row and the total number of rows in each pair is 240. That is, 40 into 6 is 240, 10 into 24 is 240, 24 into 10 is 240, 12 into 20 is 240, 8 into 30 is 240. Okay, followed here. Now this 240, which is constant, it means the number of students in a row and the number of rows are in inverse proportion. In a pair of numbers, if the increase in one number causes a decrease in the other number in the same proportion, the pair is in inverse variation. In such an example of one number of the pair is doubled, then the other is halved. Okay, it becomes half. Now let's learn about inverse variation. The statement x is inversely proportional to y can also be expressed as there is inverse variation in x and y. If x and y are in inverse proportion, x into y is constant. Assuming the constant to be k, it is easy to solve a problem. If x varies inversely as y, then x into y is constant. X inversely varies as y is written as x is inversely proportional or varies as 1 upon y. If x varies inversely as 1 upon y, x is equal to k upon y, or x into y is equal to k. This is the equation of variation. K is a constant of variation. So I hope you have followed here the equation of variation and the constant of variation. Now let us see the solved example. If A varies inversely as B, then complete the following table. A, the values are given as 6, 12, 15 and dash. B, 20, dash, dash and 4. A into B is given to be 120. Okay, then the other products we have to find out. So let's see the solution. A varies inversely as 1 upon B. That is, A into B is equal to K. When A is equal to 6, B is equal to 20. Therefore, K is equal to 6 into 20 is 120, is a constant of variation. Now let us go to the next page. If A is equal to 12, B is equal to question mark, or find out B. A into B is 120. Therefore, 12 into B is equal to 120. Therefore, B is equal to 120 upon 12. So, B is equal to 10. Third one, if A is equal to 15, find B. A into B is 120, we know that. So, 15 into B is 120. So, B is equal to 120 upon 15, that is equal to 8. Fourth one, if B is equal to 4, A is equal to question mark, or find out A, then A into B is equal to 120. Therefore, A into 4 is 120. A is equal to 30. Okay. Now, second example, if f varies inversely as 1 upon d square, when d is equal to 5, f is equal to 18. Hence, 1. If d is equal to 10, find f. Second case, when f is equal to 50, find d. Solution. F varies inversely as 1 upon d square. Therefore, f into d square is equal to k when d is equal to 5 and f is equal to 18. Therefore, 18 into 5 square is equal to k. Therefore, k is equal to 18 into 25, that is equal to 450, is a constant of variation. First case now. If d is equal to 10, then find f. F into d square is equal to 450. Therefore, f into d square is 450. F into 100, 10 squared is 100, is equal to 450. So f is equal to 450 upon 100. So zeros are cancelled. So 45 upon 10 is equal to 4.5. F is equal to 4.5. Now second case. If f is equal to 50, then find d. F into d square is equal to 450. Therefore 50 into d square is equal to 450. So d square is equal to 450 upon 50. So zeros gets cancelled. 5 9s are 45. So d square is equal to 9. D is equal to 3 or minus 3. Now let us go to practice set 7.2. The information about the number of workers and the number of days to complete a work is given in the following table. So complete the table. So number of workers, 30 workers 6 days, 20 workers 9 days, dash workers 12 days, 10 workers dash days and 36 workers upon 36 days. So let's find out. So let's go to the next page where the problems are solved. So let us see how to find the number of days. Now, here more the number of workers, then less days are required to complete the work. So the number of workers and days vary in inverse proportion. Let the number of workers be m and the number of days be n. Therefore, m varies inversely as 1 upon n. Therefore, m into n is equal to k, where k is a constant of variation. When m is equal to 30, then n equal to 6 is given. 30 into 6 is equal to k. Therefore, k is equal to 180. Therefore, the equation of variation is m into n is equal to 180. Now, the first case, if n equal to 12, then find m. Substituting n equal to 12 in the equation of variation, therefore, m into 12 is equal to 180. Therefore, m is equal to 180 upon 12. Therefore, m is equal to 15. Second case, if m is equal to 10, then find n. Therefore, 10 into n is equal to 180. Therefore, n is equal to 180 upon 10. That is equal to 18. Third case, if n is equal to 36, then m is equal to question mark. M is equal to 36 into 180. Therefore, m is equal to 180 upon 36, which is equal to 5. So, m is equal to 5. Now, let us go to the next page. We will see the other problem. Now, find the constant of variation and write the equation of variation for each of the examples given below. P varies inversely as 1 upon Q. If P is equal to 15, then Q is equal to 4. P varies inversely as 1 upon Q. Therefore, P into Q is equal to K, where K is a constant of variation. Substituting P is equal to 15 and Q equal to 4. Therefore, 15 into 4 is equal to K. Therefore, K is equal to 60. Therefore, the constant of variation is 60. The equation of variation is P into Q is equal to 60. Second, Z varies inversely as 1 upon W. When Z is equal to 2.5, then W is equal to 24. So, Z varies inversely as 1 upon W. Therefore, Z into W is equal to K, where K is a constant of variation. Substituting Z equal to 2.5 and W equal to 24. Therefore, 2.5 into 24 is equal to K. So, K is equal to 60. Constant of variation is equal to 60. Equation of variation is Z into W is equal to 60. Third problem. S varies inversely as 1 upon T square. If S is equal to 4, then if S is equal to 4, then T is equal to 5. I forgot to write T there. Just add up there. Now S varies inversely as 1 upon t square. Therefore S into t square is equal to k, where k is a constant of variation. Substituting S equal to 4 and t equal to 5. Therefore S into 4 into 5 square is equal to k. So k is equal to 4 into 25. That is equal to 100. So constant of variation is 100. Therefore the equation of variation is S into t square is equal to 100. Now let us go to the next problem on the next page. Okay. Now here the fourth problem is remaining here. X varies inversely as 1 upon under root y. Therefore x is equal to 15, then y is equal to 9. X varies inversely as 1 upon under root y. So x into under root y is equal to k, where k is a constant of variation. Substituting x equal to 15 and y equal to 9. Therefore 15 into under root 9 is equal to k. So k is equal to 15 into 3. K is equal to 45. Therefore the constant of variation is equal to 45. Therefore the equation of variation is x into under root y is equal to 45. Now let us go to the third problem. The boxes are to be filled with apples in a heap. If 24 apples are put in a box, then 27 boxes are needed. If 36 apples are filled in a box, how many boxes will be needed? Solution. Let the number of apples filled in each box be x and the number of boxes be y. More the apples filled in each box, less the number of boxes will be required. So this is an example of inverse variation. Therefore x varies inversely as 1 upon y. Therefore x into y is equal to k, where k is a constant of variation. Substituting x equal to 24 and y equal to 27. Therefore 24 into 27 is equal to k. Therefore k is equal to 648. Therefore the equation of variation is x into y is equal to 648. Substituting x equal to 36 in the equation of variation. Therefore 36 into y is equal to 648. Therefore y is equal to 648 is upon 36, that is equal to 18. So 18 boxes will be needed. Okay. Now let us go to the fourth problem on the next page. Now here the third problem can be solved by an alternative method. Number of apples in each box 24 and 36, and number of boxes 27 and x. So this is an example of inverse variation, because more the apples filled in each case, less are the boxes required. Hence 24 into 27 is equal to 36 into x. So 24 into 27 upon 36, if you solve this, you get 18 boxes. Now write the following examples using the symbol of variation. Now the first one, the wavelength of the sound L and its frequency F are in inverse variation. So x varies inversely as 1 upon F. Second, the intensity I of light varies inversely with the square of the distance d of a screen from the lamp. So I is inversely proportional to 1 upon d square. Now here the fifth and the sixth problem are deleted. Okay. Yes, we will go to the next page now. So here you can see in the above case the fifth and the sixth problem are deleted. Yes. Now let us learn about time, work and speed. Examples related to the number of workers and the time taken to finish the work are of inverse variation. Similarly, there are some examples related to time taken to cover a distance by a vehicle and its uniform speed. Such examples of variation are the examples related to time, work and speed. Now, we will see how to solve such examples of variation. Example 1. 15 women finish the work of harvesting a groundnut crop in 8 days. Find the number of women if the same job is to be completed in 6 days. Solution. The number of days required to finish a job is inversely proportional to the number of women employed. Hence, the number of days be D and the number of women be N. So D varies inversely as 1 upon N. Therefore, D into N is equal to K, where K is a constant. If N is equal to 15, then D is equal to 8. Therefore, K is equal to D into N, that is equal to 15 into 8, that is 120. Now, let us find N when D is equal to 8. So, D into N is equal to K. So, D into N is equal to 120. Therefore, 6 into N is equal to 120. N is equal to 20. So, 20 women should be employed to finish the work in 6 days. Second example. A vehicle running at a speed of 48 kilometers per hour takes 6 hours to complete the journey. How much time will be taken to complete the journey if its speed is 72 kilometers per hour? So let us go to the next page. So here, let us assume the speed of the vehicle to be S and the time taken to travel be T. There is inverse variation in speed and time. S is inversely proportional to 1 upon T. Therefore, S into T is equal to K, where K is a constant. K is equal to S into T, that is equal to 48 into 6, that is equal to 288. Now, let us find T when S is equal to 72. S into T is equal to 288. Therefore, 72 into T is equal to 288. Therefore, T is equal to 288 upon 72. That is equal to 4. Therefore, time taken to travel the same distance at the speed is 72 kilometers per hour is 4 hours. Okay, so I hope you follow these examples. Now, this practice set 7.3, the first problem fully is cancelled. The first problem, okay, yeah, the first full problem is cancelled. Okay, it's 1, 2, 3, 4 over there. Now the second one, okay, if 15 workers can build a wall in 48 hours, how many workers will be required to do the same work in 30 hours? Let us go to the next page where we can solve the problem. Okay, now here we have seen that let the number of hours be T and the number of workers be N. The number of hours to build a wall is inversely proportional to the number of workers. Therefore, T is inversely proportional to 1 upon N. Therefore, T into N is equal to K, where K is a constant of variation. Substituting T equal to 48 and N equal to 15. 48 into 15 is equal to K. Therefore, K is equal to 720. So, therefore, the equation of variation is T into N is equal to 720. Now, let us go to the next page to solve the third problem. So, 100 and now here substituting T equal to 30 in the equation of variation. 30 into N is equal to 720. Therefore, N is equal to 720 upon 30. Therefore, 24 workers can build a wall in 30 hours. Now, the third problem. 120 bags of half-liter milk can be filled by a machine within 3 minutes. Find the time to fill such 1800 bags. Let the number of bags be N and the time required to fill them be T. More the number of bags to be filled by this machine, more time is required. So this is an example of direct variation. N varies directly as T. Therefore, N into T is equal to K, where K is a constant of variation. Substituting N equal to 120 and T equal to 3. Therefore, 120 is equal to K into 3. K is equal to 120 upon 3. Therefore, K is equal to 40. Therefore, the equation of variation is N is equal to 40 into T. Substituting N equal to 1800 in the equation of variation, 1800 is equal to 40 into T. So, T is equal to 1800 upon 40, 0 z's cancel. So, 45 is 180. Therefore, 1800 bags of milk can be filled in by the machine in 45 minutes. Now, let us go to the next page and see the last problem. A car with speed 60 kilometers per hour takes 8 hours to travel some distance. What should be the increase in the speed if the same distance is to be covered in 7.5 hours? So let the speed of the car be s and the time required to cover the same distance be t. There is inverse variation between speed and time. Therefore, x varies inversely as 1 upon t. Therefore, s into t is equal to k, where k is a constant of variation. Substituting s equal to 60 and t equal to 480, we know that 1 hour equal to 60 minutes. Therefore, 60 into 480 is equal to k. So, k is equal to 28,800. Therefore, the equation of variation is s into t is equal to 28,800. Substituting t is equal to 7 into 60 plus 30, that is equal to 450 minutes. Equation of variation. Therefore, s into 450 is equal to 28,800. So, s is equal to 28,800 upon 450. After you solve this, you get s equal to 64. Hence, if the speed of the car is 64 kilometers per hour, then the same distance can be covered in 7.5 hours. Therefore, increase in the speed is equal to 64 minus 60, that is equal to 4 kilometers per hour. Therefore, the speed of the car should be increased by 4 kilometers per hour. So I hope you have followed these problems. Please solve all the exercises in the notebook. Thank you.